Hello everyone. We're doing a quick little pre-game show before we start for real. I've got some stuff I've still got to get ready. I've got almost everything aligned, but I have a ton of mosquitoes. They're just eating me up. So even though it's kind of warm, I'm still dressed a bit zipped up and long pants. I am in the middle of doing some focusing. So I'm going to go through and we're going to talk about focusing real fast. Let's see. So what I've got right now, almost there. Let's get this. So here's what we got. I have Sharp Cat Pro, and what we're going to be doing, is the focus assistant and the Batonov mask. All right, so we got nothing on here, which is fine. I have a finder on the scope that's connected, and so I can see what's in the finder, and I can see what's in the live camera that we're going to be using later on. And right now we're going to try to get the main telescope focus. So what I have is a Batonov mask on it, and I'll show you once we have that done. I currently have it on a star, and this is what the Batonov mask looks like. Let's see, I will switch to the main. So this is what it looks like. You can see pretty well right there. So what it is, there are slits cut into this piece of plastic, which then goes over the front of the telescope. Some are oriented with the axis, and some are at an angle. And the reason why we do this is we want diffraction patterns to form on the stars that we're seeing, the in focus and out of focus features. This is kind of neat because this lets us get a really precise focus when you can't get the focus just sharp enough without it. Just by looking at the star, is it a tiny little dot? Well, it's close, it's not quite there, but this lets us do it really easily. So I will switch over to that and you'll be able to see exactly what I mean. Let's get to... I need a better way of switching this thing out. All right, so I've got Sharp Cap, and now I have to put this on the front of the scope. That goes on the very front. And I tried to use an extension, and that did not work all. Hand controller, so I've got to move over. Oops. Wrong direction. That was not the direction you want. There we go. It's all. That should be pretty close. In fact, I'm going to get rid of this completely. Where is it? Now we got to hunt for it. So this is always fun. 46, yeah. So I'm going to go back to the controls. We'll hunt for it. Lower. Oh, wrong direction again. It's always the wrong direction. For what you pick, it's always the wrong direction. Uh-oh. There it goes. Barely moving. There it goes. Oops. In the other direction. Kind of clicking away. There's something. Oh. Almost there. This is why it's the pre-game show and not the live show. Y'all can hear me. Should be seeing something. Anything at all. Anything at all. Anything at all. Come on. Come on. Come on. I just had it. So one of the problems is I've got a lot of power on this scope. And it's sometimes a little bit hard to get it just right. But I'm trying. I'm really trying. Hello?
Hello.
We're doing a pregame show. And this is kind of a boring pregame show. I know. I'm trying to find exactly where this is. And I thought I had it. But I guess I didn't.
Mama.
Careful of the cables. Oh, man. Alright, so here's what I have to do. I will... Oh, yeah. Okay. We're going to do it the hard way. Alright, here we go. Got this. Alright. This is an out-of-focus image of a star with the mask on it. And if I rotate the mask without touching the corrector, see that the spikes are actually going in. You actually see the spikes there, the pattern, as I do it. So what I'm going to be doing, getting this close as I can to focus. I'm going to swap out the camera. Whoa. Right. Put the Barlow back in. Put the eyepiece, the lens back in. I know roughly where it is. There it is. Up good. Oh, we're close. Uh-oh. Uh-oh. What was that? What was that? Someone's playing with tools. Watch out for the cables. Right. So, got a star. And what I'll be doing now is bringing it in and out of focus so you can kind of see what's going on. First of all, see what the pattern looks like in and out of focus. And this is very close to focus. And this is out of focus in the opposite direction. And what I'm going to do right now is recenter this thing so I can get it right on. Okay, so what I need that to do, I need that to look really, really good. The way I do it is, I get it.
Hello.
Hi. Something like this. What I'm trying to do, get the image symmetrical. Okay? So for these colored spikes that you can see, oops.
What are those?
These are colored spikes. They're called diffraction patterns. And diffraction patterns are really, really important for us because this lets us get a good focus. So we're going to do bad enough mask. Okay. Gonna go down. So there we go. So now it's trying to figure out how close to a good focus is this. And it's not that good.
I see an airplane.
So what do we have to do? We have to get it a little bit better. And you just pretty much just play with it. Whoops, wrong direction. Get the other direction. She went inside. Let's get this recentered. Usable. There we go. So what are we doing? We're looking at the pattern and we're seeing what type of focus we've got. Okay? I gotta get it closer and closer. We want it ideal, and it's not ideal yet. That's not too bad. I like to see it in the green, so Taking a little bit of a peek. Let's see. Try a little bit more in that direction. See what happens. So now we're going back up. We didn't want to go in that direction. We wanted the opposite directions. Now we're going back counterclockwise. And that's actually a little bit better. Even though there's that orange spike, we're actually better right now than we were. We don't want red, but part of it is also seeing. But that's not too bad. It's still not quite as symmetrical as I like it. So let's see if we do this. Rotate it. Well, I don't want to rotate that direction. I want it the other direction. That'll work. So what are we seeing? It's close, but not quite where we want it. So let's go back clockwise. A little bit more.
The Minky one.
Good.
Look, everyone.
They can't see you there. The camera's over here. There we go. There we go. That's much better focus. A little bit more. Let's hope we didn't screw it up. We did. Maybe. Tiny bit. Yeah, tiny bit. Let's a little bit back. Now, nice thing about a motor focuser is that it gets really, really precise. A lot preciser than you can by hand. So, yeah, jeez. Watch my feet. All right, what we got? Sebuś nie chodź tam. Okay, how's that for focus? That's kind of, it's not bad. Part of it is also seeing. I think I can do a little bit better. Bring it down just a notch. Yeah. All right, I'm going to call that good for now, I think. I think we're actually pretty good on focus right there. Well, maybe time to starting get better. Maybe not. Better? Is it worse? I feel like I'm an optometrist now. All right. Kind of what we want to see, though. Now it's getting worse. Well, I think part of it is seeing. It's just what it is. I think that's probably, man. See, it's part of it is also we're chasing seeing now. Is it better like this or is it like this? Better like this or is it like this? We found a good mean, I think. I really can't get it any better right now. This is as good as it's going to get. So let's recenter. Now this is just a star. This is just a star, and the reason why we do a star is stars are essentially point sources of light. So we want to see just a point source of light. All right, so let's get rid of the Batinov mask. Yeah, I think this isn't bad. All right, so we have a star. So this is the pattern that we're seeing, and this is actually a quantum mechanical effect of the light passing through these slits and showing particle wave duality. So it's a really simple experiment, but it works out pretty well. And the spikes are mathematically calculated so that they're fairly easy to see, and it's easy to see when they're symmetrical. And that right there looks pretty symmetrical. I'm going to bump up the exposure just a tiny bit so you can really see the rainbows coming off. Now this is, because they are slits, it is being split apart like a rainbow. This is a diffraction pattern. So It's not exactly diffraction grading. A diffraction grading is usually something with a lot finer patterns, a lot finer scratches onto a piece of plastic or a piece of glass. These are much larger, but you can still see the effect. So again, really, really cool. This actually does show wave particle duality. So pretty cool. Let me see if I have any questions. Okay, yeah, I can turn down my gain. Where am I? What is my location? So we're in Burleson, Texas. We're just south of Fort Worth. I am in my backyard. Um, let's see, what's my sound? Sound should be fine. Let's turn on the gain. Gain, we can turn it down. Nah. Turn up the gain way a lot. There we go. We don't really want the gain very high. All that does is introduce noise, but you can really, really see the pattern now. It's really, really obvious. And now you can see it's not exactly symmetrical. Well, back to the drawing board, eh? So let's see what the Batonov mask says, what our focus is. It's not bad. It's going to be pretty good, but it should be fine. I think someone's texting me. Okay. All right, cool. So I'm technically on call, but one of my coworkers is going to be taking over. So it's close, but it's not quite. So let's get it a lot tighter. All right, first one direction and the other, right? Better. Tiny bit more. There we go. That's going to be pretty good right there. I'm pretty happy with that. Boosting up the gain and the exposure, let us see those spikes. It makes it a whole lot easier to see where the focus is. This is good. This is good. I'm pretty happy with it. All right. Let's see. Okay, so we can call that. And I'm going to go ahead and get it on Jupiter while we can. So let's see. Let's see what we can see. Right now, we're going to have to wait a bit for Mars because it is still not over the tree line. So we can do some Jupiter and Saturn in the meantime. And here comes Jupiter on the finder. I'm going to kill this here. Yeah. It's close to the finder, but not quite. There we go. All right. So right now we are synced on Jupiter, and I believe, not really sure what that is. Let's go ahead and kill way down. Whoa. All right. Take our gain way down. I don't want so much noise. We had a what, 150? Now we'll play with it. I typically have this up in the 20s, so it's not too bad. All right. So there we have Jupiter, and I'm gonna move it just a tad. All right, here we go. So we have Jupiter. Now, there are two things to realize right now. Number one, um, it smells kind of burny outside. So it looks like we have grass fires or forest fires, which are sending up some haze. So right before sunset, I did notice that there were some low-hanging clouds, kind of haziness, maybe not exactly clouds, but something not terribly pleasant right now. So I can still smell it, and it is introducing a bit of a haze. So we'll see how this goes. But in the meantime, we do actually have Jupiter here. So this is working. It's just kind of not nearly as sharp as it was, but we can play with that somewhat. I'm going to boost this. I want to see what else we can see. And I think we had, oh, what did we have? We had Io, let's see. Uh-oh. Wrong one. Let's do labels. I'm going to jump onto planets and moons. So what I'm doing right now is I'm taking a look on my other screen at my program. Let's see, where's Jupiter? Jupiter, here we go. Center. And what do we have? Io. All right, so this over here is Io. And if you notice, it doesn't look like it's much in focus. Well, maybe there's something else going on. So let's see if we can get Io a little bit closer to focus. And what time is it? We have 15 minutes until we're starting. That's not too bad. Let's see. I'm going to go through any questions. Let's see. Up the gain. Turn your exposure down. Yeah. All right. I am not using filters at all right now. It's pretty much just a naked sensor. I could put an infrared filter on there. I guess I have one somewhere. So many filters. I think I got it somewhere. But more glass in the path. What am I doing though? Does this use SCR files? Yes, it does. So I can output the format in not auto, SCR, AVI, PNGs, FITs, JPEGs, TIFFs, and WMVs. Nobody cares. I typically do SCRs or AVIs. FITs and TIFFs are just fine too. But I have issues with performance on mine. So if I use FITs or TIFFs, then that also means that my memory starts using up and then I start dropping frames. So let's take a look at Io, because Io is not really that big. Let's see if we can just focus it down. I'm going to ignore what our mask told us. Oops. Move it over slightly. Go. I just eyeball it. All right, fine. Let's do the mask. Let's see what the mask does on the planet. It's not exactly a point source of light, but maybe we can get something out of it. Turn up the gain. Where's my gain? Get gain way up. Ah, there we go. We got gain. Let's just eyeball this thing too. Is that better? Better or worse? Oh, that's a whole lot worse. Why did I do that direction? Is that better? Worse? Tiny bit back. Oh. Close. Come on. No. Wrong direction, the other direction. Close. Too far. Isn't this fun? Focusing. Worst, absolute worst part of this. Focusing. Getting the focus just right. And it is still not right. How's that? Oh, I can't tell. It's just so... Alright, I'm going to turn down my exposure so it's just a lot faster. Let's turn the gain way up. That's actually easier to see. And that's going to be pretty symmetrical. It's better than what it was. Right. And the seeing isn't fantastic anyway, so we're going to deal with it. So we got Io. Wow, that is noisy. Alright, we got 10 minutes till the initial start. So I'm going to knock this way down. There's Io. Let's get the gain way down. And then you can see Jupiter. That looks a bit sharper too. So I'm going to center Jupiter out again. Isn't that pretty? Unfortunately, the way I have this set up, I've just got to keep coming back and forth. We'll do telescope control on here. Disconnect. Connect. Let's see if it'll let me connect. Yeah. Figure. Properties. COM port 3. Alright, fine. Connect. Connect. Yay. Good. Alright, so we're connected. We got Jupiter. We got 10 minutes, so I'm going to go ahead and I'll switch back to our intro. And I need to get myself something to drink, get ready, and then we will start in 10 minutes. Let me take a quick look. I see no Mars, so that's not exactly great, but well, it is what it is. So I have a couple text messages to send out, and we will go ahead and see you again in 10 minutes. Hello and welcome again. I'm Chris Wojnicki from the Fort Worth Astronomical Society, and we're here again doing a little impromptu, last-minute observing session. So what are we doing right now? Got everything set up, everything is configured, and we did a little pre-game show, getting some focusing in, testing a couple things out. I think we've got everything locked in, maybe. So today we are in Burleson, Texas, just south of Fort Worth, in my backyard. When we do planets, we don't really need to be out in a dark sky site. And right now, one of my mount is pretty much out of commission, which means that instead we're using this. This is the Fort Worth Astronomical Society's library scope. This is a Celestron CPC 1100. This is an 11-inch Schmidt-Cassegrain F10 on a fork mount. It has pluses, it has minuses. The pluses is that it can be very easily set up. It's very, very easy to use. It has a GPS, so pretty much you can, with a couple clicks of the buttons, align it and then use it to start observing. There are some downsides. Because it is an F10, because it has such a long focal ratio, and was it 2,000 millimeters, and also because it's because it's an F10, it's very slow, which means it has a very narrow field of view, even for very wide eyepieces. So this is not something that that you can use to see things like wide, big, huge nebula. You don't want to do that. Instead, this is perfect. Well, not perfect. This is good for planetary stuff. So without further ado, let's go ahead and switch over. So here's what we got, and it looks like I'm going to have to recenter it. Okay, here we go. What are we doing tonight? We're looking at planets. We were looking at Jupiter, at Saturn, and primarily at Mars. However, Mars is not yet above the horizon, or at least not above my tree line. So we gotta wait a little bit for Mars, but that's okay. We can do stuff like Jupiter, and we will do some live stacking so we can get a much, much clearer image than what we have here. So first, Jupiter is not centered in my field of view. Let's go ahead and get it centered. And unfortunately, what I tried to do earlier to get this thing to work did not work. So instead, I have to get up and move it manually every single time. And for those of you who have joined us before, I am over the flight path for Spinks Airport. So, yeah, we have airplanes that fly overhead. Right now it's just after sunset, so they're practicing nighttime landings. All right, here we go. So we're looking at Jupiter, right? And over here, I believe we have the Great Red Spot, which is just coming over the horizon. Should be seeing it a little bit more in just a tad. So that's actually not too bad at all. I did have some of the moons up, but if I bring up the moons, then we pretty much have to blow out Jupiter. Here we go. So here we have Europa right there. Little moon of Jupiter, and on the other side we have Io. It is off screen, but they are small. We're not going to see any details on them anyway. And when we blow up, when we expose long enough to see the moons, Jupiter gets overexposed. So we're going to turn that up to about 120 or so. Let's get 115. That's good. So let's talk about what we're seeing. We're seeing mosquitoes. We're seeing a ton of mosquitoes. I did get that one. So at least there's that. All right, what are we seeing? We're seeing Jupiter, and we are seeing the South Pole here. We're seeing the North Pole here. The telescope does invert it. And we can see some of the banding. We can actually make out some of the colors in the banding. But it's kind of fuzzy. It's not quite that sharp. And one of the reasons is we have haze right now. So just being outside, we talked about this during the pregame show, I can smell some smoke in the air. And it was a bit hazy right about sunset. So we have to see through that haze, and it's not making it too pretty. That's okay. And I guess you can hear the highway in the background as well. So there are pluses, there are minuses being out here. All right, so what are we doing? We're seeing atmospheric hazing. We're seeing some of this atmospheric distortion. It looks like the image is kind of wobbly a bit. So what do we have to do to make this better? We're going to do something called lucky seeing. And what lucky seeing is, we're going to take a video. We're going to start capture, and we're going to drop this into an SCR format video. This is something, I can't remember what type this is, but it's pretty popular with astronomers. It is a lossless format, means it just takes frames, as many frames as it can, and then just turns to a video. So we're dropping some frames, but it's not too bad. Excuse me, it is kind of dry out here. So I do have my water. What we want for this kind of viewing is as many frames as we can get. And in some cases, people will take images for 10, 15, 20 images or minutes, string all of the frames together, and then we'll bring it into another application. And let's see if I can get it. So those are some images that I took this weekend, and we can look at those last night. But I want to get into something specific here, and there we go. So we're going to use AutoStackert, which is a neat application. I tried doing this with Registax. Registax is another application for doing stacking, and it did not work terribly well for me. So what I want is as many frames as possible. We got 500 frames so far. It's not too bad, especially in a minute, 20 seconds. Something that is really, really important when people are doing visual observing, when they're just looking through the telescope, and that's all that they're doing. Just regular eyepieces, no video, no cameras, nothing, no photography. They're just looking through the eyepiece with the eyeball Mark 1. Visual observers will sit at the telescope, sometimes on the same target, for minutes, even an hour or longer. It's not just a quick glance, because a quick glance, you're just going to see a little bit, there's going to be some atmospheric hazing. And what visual astronomers look for is these perfect moments, 1, 2, 3 seconds, when the image just perfectly stabilizes, you can make out a ton of detail, and then it all goes hazy again, and wibbly wobbly. Those are the moments that visual astronomers wait for, and it's worth it. When you get that clear view of something, a crater or a rill on the moon, looking at a planet, seeing something just super, super sharp, that's what they want, and it's really, really impressive when you do it. With the video, it's a little bit different, but what this allows us to do is gather a whole lot of frames, and once we've gathered all the frames we want, we can toss out the stuff that's not that great. Toss out the bottom 50%, toss out the bottom 80%. Just take the best of the best frames, and then we stack those. And what stacking is, you just kind of, you put the images, think of it like a stack. You put them one on top of the other, and using that technique, you can get a sharper, better image than you can with just one of these frames. So we've got 1,200 frames. That should be good for now. We're just doing a test, so I'm going to go ahead and do a stop capture. So we picked up 1,264 frames. That's not bad in 3 minutes. So AutoStackert, let's go ahead and do this. We're going to do open and go to, what did I, I don't know what I saved this as. Capture. Okay, I forgot to name this. That's okay. So here we go. What are we stacking? What do we got here? Oops, where's this? We're going to get this back. And the reason why I want to show you kind of the bit about how the sausage is made, because it's not, you see all the really, really neat pictures online. You see the, like today's astronomy picture of the day, images of Mars over the past several months as it gets bigger in the sky, bigger in the telescope. It's neat. It's really, really neat to see those images, but especially if you buy a telescope and you look through a telescope, you probably will not see those images. You may see something similar, but again, it's that lucky seeing. It's those only few moments, and you've got to sit there for sometimes even hours. So I don't want surface, what I want is planet. There we go. And we're gonna pick some points on here that I wanna make sure get grabbed. Pretty much anything like this. What do I usually do anyway? All right, so we got that. Next, gonna hit analyze. And we're gonna let that thing go. So I'm actually gonna grab this and I'm gonna toss it onto my other monitor. We don't necessarily need to see what's going on here. We can still look at Jupiter. I can watch the status of it on the side. So we have the banding, we have the clouds, and on Jupiter we have the different coloration. Why do we have different coloration? Some clouds are actually at lower level than other clouds. The darker reddish clouds actually bring up organic compounds from deeper in Jupiter's atmosphere. The wider banding, I believe that's ammonia, higher up in the atmosphere, also with fewer of the organic compounds. And all right, here we go. So we're going to stack. There we go. So we can see kind of a graph of images. Let's do stack. Let's see how long that takes. Shouldn't take too long. 18%. All right, let's do that. 64. So let's see what it does. I'm bringing up exactly where this is on the other one, and then capture. This is actually from last night that I took. I'm going to, let's leave it on here. Whoops. Let's see, where is the image? There we go. All right, cool. So we're going to bring Jupiter into here. This is our stacked Jupiter. And you can see it's still kind of fuzzy, but we're actually picking up some details. It looks like there's something reddish over here. So that's probably the great red spot. So what can we do? Let's crop this thing down first. So this is usually something done after a night of imaging. But now, let's do it here. So I'm not going to do anything terribly special with this. There's a whole lot of stuff that can be done. I'm going to use unsharp mask. I can remember. Here we go. So post-processing, something you do the next day. Yeah, here we go. Oh, there we go. Now we got a gray red spot. How many levels we got? Now we want it way down. So I am on purpose overblowing this a lot. Okay. Oops, wrong way. There we go. I am seriously, there's a lot of noise in here. I'm boosting the colors. I'm doing a whole lot to this. And honestly, it looks pretty ugly. But we can now see a little bit of the structure. We can see some dark patterns here, and we see a red spot right there. And we know this is the great red spot. Why do we know it's the great red spot? Because the great red spot sits, another mosquito, sits in between two bands. It's actually rotating between them. It is not in one band and not in the other. It slides in between. So these bands are orbiting. Now let me rephrase that. The winds in these bands are moving in opposite directions. So I don't recall which one's which, but I think this one rotates in this direction and the white rotates in this direction. And so you get these areas of turbulence in between where there's shear on this side and shear on this side, and you have these vortices that form. And the great red spot just kind of moves along and moves along and moves along, and it rotates along the same direction as those vortices do. Let's see. Anything. Yeah, stacks did make it a little bit softer, but that's fine. Keith is asking, did I use auto stacker for this Mars I did the other day? Yes, I did. So if you saw on the Facebook site for the Fort Worth Astronomical Society, I uploaded, I believe it was this one. Well, let's see. So I'm going to bring this way down, and we'll play with it a little bit differently. So unsharp mask, I want to get this down. Yeah, that's good enough for now. So this one for Mars, yes, I did go ahead and do this. Yeah, this was from last night. So we'll see a little bit different today. I believe we're going to be looking at Hellas Planatia, or the Hellas Basin. which is a big impact feature in the southern hemisphere. So we got Jupiter here. We got Jupiter here. Oh, time to move it again. Hang on. Almost there. So this is another disadvantage of this telescope is, at least this one, the gears are a bit sloppy, so they're not as tightly meshed as they need to be. So I will have to take it apart. I will have to do what's called a hypertune. Take it apart, you clean it, and then you tighten up the gears so that they're as tight as possible without really stripping each other. You want to minimize backlash. And what you're seeing, and I don't know if you heard, there's like a clicking sound. That's part of the backlash, where the gears don't exactly mesh up just right, and the motors they're attached to, they try to move, and it clicks before catching, and then it moves. So, but that's what we got. Also, found out working on it this past weekend that I can't use the auto guide in Alt-Az mode. Alt-Az is up, down, left, right. I need to put the equatorial wedge on here, and with the equatorial wedge, it'll be an equatorial fork mount. Then I'll be able to do auto guiding. So that's a limitation that Celestra naturally puts into the firmware. It is what it is, just deal with it. So we've got Jupiter. That's not too bad. And did a little bit of editing, but yeah, it's not quite as sharp as I like. I think what we'll have to do is really more video. Just take more video of it. And what you can do is actually set this up so you take, let's say, 5 minutes at a time, and then you stack 5 minutes, then you stack the next 5 minutes, the next 5 minutes, and you do this all night long, and you can actually create a time lapse overnight of a planet rotating. And Jupiter rotates pretty fast, once every 12 hours. So, on a good night, not now when it's closer to opposition, you can take 6 hours worth of video, and then you have half a rotation. The Martian day is pretty close to where Earth is. I think it's just under 24 hours. It's just over. I don't remember how long the Sol is, but it's different enough that we have to use sols for Martian days than instead of Earth days when dealing with probes and things like that, so we can keep track of it. And people at JPL are actually on sol schedules, not on day schedules, when they deal with probes. So do we have any other questions? Have I tried Registax? Yes, I have tried Registax, and Registax does not like big SCR files. I was playing with it earlier today, and I tried to dump in a 24 gig SCR, and it just said nope. So no. It did handle some smaller ones, but I didn't want to mess with it anymore. So just left it at that. What else we got? So we got Jupiter, and that's not too bad. So what I'm going to do is I'm going to show you what I can see. Whoops, wrong one. There we go. Here's what I've got in my other screen. So this is where my finder scope is. So you can see there's Io. We have Europa right there. Oops. And Ganymede is right there. And we have Callisto way out here. So these are the 4 Galilean moons. So these are the ones that Galileo found first with his tiny little telescope. Hello. I thought you were going to go to bed. Say hi.
Hi. Hi, everyone. Welcome.
Camera's there.
Hi, everyone.
So Sebastian is just about ready for bed. He's had his bath, right? And are you ready to go? So what are we looking at? What are we looking at? Do you know?
Yep.
What are we looking at?
At Jupiter.
This is Jupiter. How did you know?
Because I'm looking at here and here.
Okay, good. So at least he can recognize planets. That's a good point. All right, what do you want to look at next? Do you want to look at Saturn?
Yeah.
Okay, let's go ahead and
I
move it to...
love Saturn.
Good. So we're going to look at Saturn.
Saturn.
I'm going to bring up my finder.
Saturn.
So I'm going to go ahead and go back to the scope and dig up Saturn. So let's see. Remember, be careful around the wires.
Why wires?
Okay, so Saturn is close to Jupiter. And there it is. All right.
I also want
Moving it over. Hopefully it will go well. Yep, wrong direction. Hey, are you in my space? You're in my seat, right?
Hello, everyone, and welcome to the virtual star parties.
Say like and subscribe.
Like and subscribe.
Here we go. Okay, so we got Saturn. No, you can turn off the light, please.
I like this light.
All right. Okay. All right. Now you got to move.
I'll move, and now you sit.
Yes.
And
Okay.
I'm sit.
So now we can see Saturn, and Saturn is a lot dimmer than Jupiter is. So it's a lot further away. It's a bit smaller. So we have to turn up our exposure. I don't want to turn up the gain because that just adds in noise. But there we go.
I want gain.
No, we don't want gain now.
I want
We want longer exposure. Well, maybe shorter exposure. All right, let's see what happens when we bump up gain. We'll just, ooh, well, that may be better. That's too much. So it's that sweet spot. And that's not bad. So we want a shorter exposure, but a little bit of gain. We'll deal with the extra noise. It's fine. I'm going to go over because I need both my hands. He's sitting on my lap. Okay. Ready? Okay. So we got Saturn,
You know
right?
I'm ready. Shh. Every time you know I'm ready.
Okay, so we've got Saturn. What we're looking at here, we can see the Cassini division. So the Cassini division is named after an Italian astronomer who was the first to be able to see a dark band in the rings, because they didn't know exactly what this was at first. So what are we seeing right here? We're seeing Saturn.
That was the dust and the
Ice.
the ice and the rocks.
Ice and rocks. So what we're seeing with the Cassini division is things like shepherd moons. It's basically a bigger chunk of rock in the area of the ring that is selectively speeding up and slowing down the material around it. It is gravitational attraction. It is a slingshot effect, and it throws some material out and it throws some material in. So it clears out this path, and they're called shepherd moons. And also, looking at the rings, they look big, they look substantial, they're reflecting a lot of light. The rings are, on average, about 10 meters thick, so 30-something feet. Not very much at all.
Guys.
But we can actually see this easily. Now, there are certain times in Saturn's orbit when the rings go edge onto us, and when they do, they pretty much disappear. We just can't see them anymore. What we can see in this image right here, that dark spot right through here, this is the shadow of Saturn being cast onto the ring behind it. We're just at this angle where the sun is coming in from this direction, and we can see the shadow here. So that's actually pretty cool. We can also see a band right through there. So what we're going to do, we'll just do a quick capture. Start the capture. I could probably just do, let's just call Saturn so we know. Saturn. We'll do capture. Let's go. So how many we got? 12 frames, not too bad, but we're a lot slower than Jupiter. We have to have a slightly longer exposure than Jupiter. but we're bumping up the gain because it is a dimmer object. So we just deal with it as we did. So Hector's asking, are we going to show Mars? Yes, I'm going to show Mars. However, when I'm looking, Mars is just barely above my tree line, so we will get to it. One of the issues with shooting stuff low on the horizon is that you have a lot more atmosphere you're seeing through, and we have some haze that we're dealing with. The horizon's all around us. The horizon is where the ground, the earth, meets the sky.
Here's the horizon.
That's not the horizon, that's the zenith. These are pointing up. So, yeah, let's see. Okay, so I got some frames, 200 frames, and it's getting to the edge. Let's go ahead and stop it. I'm going to go ahead and bring up ASI again. We're going to go ahead and open up the next one. Let's see, you get capture. Here we go, Saturn. Let's just see what we can see. So, we got planet, dynamic, analyze that thing. We don't have a whole lot of frames, it'll go pretty fast. Okay. Alright, so here's what we're seeing with this. Move it off onto my other monitor and go ahead. Quality's not half bad. Let's go ahead and stack it. Yeah. See what we got. All that thing's going. Here we go. Here we go. Still saving. There we go. Now we got something. All right. We got Jupiter. Let's get Saturn. There we go. So we're dealing with similar sizes. Let's go ahead and crop it to each moment. Watch out for cables. So many cables. Yeah, it's still pretty soft. All right. We need a lot more frames, not just 2 minutes worth. We need something. We need some serious. So stylize. Oops, nope, sharpen. You know what? Before we do that, let's do this. So there's some other tricks we can do. Adjustments, levels. We want to do levels. So this is white. This is black. We got a lot of black. We got almost no white. Can do this. Bring white down, so we can stretch out our levels. We can see a little bit more detail. We can see a bit of a Cassini division right there. We can see that, but it's still a very soft image. Let's just see what we can grab. There's also stuff we can do with curves. I'm not going to mess with it too much. Curves, we can bring it down. Yeah, there's not a whole lot. I want to mess with curves. That's not too bad. Yeah, we'll deal with it this way. So we got, let's see, filter, sharpen. We'll do the unsharp mask again. Whoa, that's way too much. What I want to pull out is just a little bit of the detail. And I'm not able to pull out too much. We can see some banding right through here. We just need a lot more images. This just isn't anywhere near enough frames, and I should probably do a whole lot more with the stack. Get it looking a lot better, but let's just do that for now. So this is not what we really want. What we really want is a vertical flip. This is how you're actually seeing it in the sky. When I'm looking up at it in the sky towards the south, the sun is to my west, so the light is shining up in this direction from the point of view of the planet when you're looking at it in the telescope. So this telescope will invert the image. It flips it just upside down. It doesn't do left right. So this is the way it would appear if you had a like a really powerful set of binoculars that you're using to look at Saturn or at Jupiter. Somebody walking back there? Somebody's walking back there. So he's looking at the planets as well, naked eye. Let's see, what is... Mars is pretty bright. So if I'm looking at it right now, I'm trying to get this out. Plane? Yes, I know. Lots of planes. Be careful of the cables. All right, got Saturn. Let's go ahead and do Mars. So, Okay, so we got yes. Anything more than 3 minutes, it will cause some distortion. However, you can do rotation. You can automate that as well, so it'll fix it. I believe these images will be a lot better once I get the wedge in. With the wedge, I'll be able to do better tracking, and especially once I clear up all the slop in the gears. So the image will be more stable. It won't jump around as much, and that will make for better images. All right, Mars. Want to see Mars? Are you ready for Mars? We're not gonna. All right, so let's do this. We got to jump to here. Ah, it's gone. The Saturn's gone. That's fine. I want to bring up. It's drifted off the field of view, so I'm going to go ahead and let's go ahead and bring up Mars. It's what we're here for, right?
Yeah.
See how close this is. All right, so Mars is pretty low to the horizon. I'm guessing it's going to be swimming a whole lot more than Jupiter or Saturn. But it should still be pretty visible. What are we looking at? So we'll be looking at the southern hemisphere.
A bug is on your telescope.
A bug? You mean on here? Where's the bug?
Here.
Oh, yeah, there are lots of bugs. They like the light. Okay, go sit down.
They like bugs.
All right. Be careful you don't catch your fingers. All right. So they can't see you on camera. You have to sit up higher. Okay, so this is close, but not quite. All right, there we go for that.
They can't. I can see me.
I want to see Mars.
Even though you're cute, not everyone wants to see you. Okay, so I'm getting Mars right now onto the guide scope, or the finder scope in this case. And there we go. All right. There's Mars. Don't touch anything. So many bugs. All right, got Mars, right? Well, Mars isn't nearly as dim as Saturn, so we got to crank this way down. Oh, here we go. Hey. But that is, oh, look at all that atmospheric distortion. That is just swimming. So what if I play with the gain, take the gain down, a little bit longer of an exposure? Oh, man. That's just, I don't think Mars is quite yet ready for prime time. I think, I really think it needs more time. Uh-oh. Uh-oh. Oh, no. Did you touch something?
No.
Are you sure?
I know.
Okay.
I did touch this.
You didn't? Okay.
I touched this where?
Okay.
This.
Well, something just happened to
the planets.
Something just happened to Sharp Cap. We had a crash. All right.
Okay. Use the time to say good night.
Are you going to bed?
I'm going to bed.
One more time.
Good night. I'm going to bed, everyone.
Bye-bye.
Bye-bye.
Good night.
I'll see you.
Okay, let's restart Sharp Cap. I'm not really sure what happened. Just a crash. So, just restart. Okay. Sharp Cap. Let's get a camera. Pick the right one. Anything? Let's see, 39. It's somewhere. All right, it's moved off. Again, slop in the gears. Let's get it back. There we go. That clicky jumpiness is yeah, not the greatest of things, but you can see there's just a whole lot of atmospheric distortion right now. It's just, oh, it's so wobbly. The haze isn't exactly helping, but oh man, that is so wobbly. I'm gonna turn this way down. Let's get fast, but I'm gonna bump up my gain. This is just gonna make it super, super noisy, but that's okay. You can see it's not quite Jupiter sized, but other than Jupiter, it's gonna be the brightest thing out there. So what are we looking at? Oh man, this isn't nearly as nice as it was even last night. I'm gonna jump here onto Mars. Come on. Not tomorrow. So home. I'm jumping view. So what I'm doing right now is I am using Starry Night Pro. We're going to turn on labels. This is the application I use to connect in to the telescope, to control the telescope. Usually when it's my other mount, in this case, it's just not quite as accurate as I like. So I'm going to do find sync on Phobos. So I should sync on Mars. Sync on Mars. There we go. And select center. Now we're here. So what are we looking at? We're looking at a south pole. This is the southern ice cap. But this is also the southern summer. So the ice cap right now is at a minimum. The northern ice cap is currently all in shadow. We may be able to see a tiny little bit of it. I think we saw some in previous images that I've took, just barely something up there, but most of the northern ice cap is going to be hidden. What we see here, this is Hellas. The Hellas Basin, let's see, where is it? Mark Hellas Planitia. So Hellas is a deep depression on Mars. This is the site of an impact, and this is below Martian mean sea level. So basically, if you kind of, there's like not exactly an arbitrary, but there's a sea level for Mars. This is well below sea level. Then you have most of the upper latitudes of the northern hemisphere. They are also below sea level. So if Mars had oceans, what you would see is a big sea here, and then a great northern ocean as well. So let's go back to here and let's see if we can see it. So where's the ice cap? We should be able to see the ice cap here, but yeah, it's just not. It's not quite there yet. So the ice cap is right there, and Hellas is right here, the Hellas Basin. So I'm going to jump back to Photoshop so we can get what I saw previous night. This is what we should be able to see, is a white patch, which is the southern ice cap. And this is not Hellas. This is from, this is just not. So I don't think it is. This may be Hellas over here. I can't remember off the top of my head. But we could really see some details last night that just aren't coming in yet now. This peak here, right there. Okay, so we can't see Hellas. This peak right here corresponds with this peak right here, this dark gray area. And what we're seeing right now is basically the lighter stuff here. Anything that's light colored is going to be, it's like a desert or a depression filled with dust, with sand, things like that. And the darker areas are typically highlands, typically mountains, or you can really say it's rock, as opposed to dust. So it's mountains, it's hills, higher areas where the rock is exposed. And the lighter areas are lower areas where the dust and sand kind of, the wind pushes it into. So, yeah, back to here. So that's what we're seeing. That's what we got. So it's still early in the night, even though it is 9:10. So it's still early. We're not seeing it really super nice. It's low in the sky, so we have atmospheric effects. We have some haze. That's not terribly helping either. And I'm going to recenter it. Let's see. Yes, I am getting up a whole lot so I can keep moving this. That's one of the disadvantage of this particular scope. Again, it's just gear slop, so I've got to fix it. There's not much more I can do now. I have really high magnification on this. So this is 2,000 millimeters, and I have a 2x Barlow on it, so it's equivalent of a 4,000 millimeter telephoto lens. I think that's a helicopter flying overhead. So while that thing's flying overhead, I will go ahead and fix the centering. Let's see. Just have to get those gears meshed just right. But it is annoying. It is annoying to get up, but well, we'll deal with it. What if I boost the gain up a little bit more and turn down my exposure? That doesn't really help. We're just seeing just a whole lot of atmospheric effects. Yeah. So that's what we got. Now, in another hour, 2 hours, it will rise well above the horizon, and the atmospheric distortion decreases a lot. Last night, I think I was out here till about midnight or so, so it was much higher in the sky. And Saturday night and Sunday night, I think I was out till almost 2 a.m. So the imaging got much, much nicer. Let's jump back to here. So this is what we're seeing on Mars, that peak apparently. I wish we could, yeah, I wish we could see a little bit better, but I can't. If we could see a couple of hours in the future, no, we would see Valles Marineris. So this is the Great Canyon on Mars, and it extends over 1,000 miles. It's quite, no, more than that. I think if we laid the United States on Mars, this would extend most of the way across the United States. That's the equivalent distance. And we got Phobos. So what time is it? 9:13. Yeah, 9:13 is now. We can't see Phobos. This is one of the moons of Mars. It's just too tiny to see from here. With a big telescope, it'd be doable, but not with this thing. Where would it be? So if we're looking at Phobos, it is on the opposite side from the ice cap. So we know that the ice cap is over here, so Phobos should be somewhere over here, but it's too tiny to really see. Okay. All right. Olympus Mons on this side. No, Olympus Mons is not on this side, John is asking. Olympus Mons was visible when? Earlier. Oh, it's on the opposite side. There it is. So here is the Tharsis Bulge. I believe here's Olympus Mons. Let's see. Elysium Mons. So yeah. Yep. So it'll be over here. Here's Tharsis. These are 3 volcanoes, and I believe here is Olympus. No. Yeah. Oops. Let's zoom in on there. If I zoom in too much, it will go below the horizon. Yeah. So I believe Olympus Mons should be over here, just at the edge. So the Tharsis Bulge is a big upwelling of magma from the Martian mantle, and at one point, I don't remember if it was in the northern hemisphere or it was in the southern hemisphere. I want to say it was in the north, but so much material came out that it actually shifted Mars's rotation. Its entire axis of rotation shifted over to put that big mass closer to the equator instead of near to the pole where it was before. So it's kind of neat that volcanoes are actually able to do that. Oh man, you can't even see. There are moments. There are moments when you can sort of kind of halfway see the ice cap. Turn down the gain. A little bit longer exposure. Yeah, this is smoother. There's less noise. Now I gotta get up again. And yeah, Jim's saying that his stays centered. Yes, you don't have the slop that this one does, so I've got to fix that. There we go. So I was thinking about looking at some other stuff, Neptune and Uranus, but with the seeing that we have right now, that's it's kind of iffy. Uranus is also on the same level as Mars, if I recall. Let's see. Oops. Let's zoom back out. So here's Neptune, and Uranus is still below the horizon. So Neptune's not terribly easy to find, especially in the haze, but it is basically a little blue disk. And we can try to hunt it down while we wait for Mars to come up. Anyone interested in seeing Neptune? Let's see, any other questions? Yeah. So am I using any filters? No. I have enough glass in the path as it is. I've been messing with some things and trying to get it working. But yeah, there's a whole lot of glass in the path anyway. So adding in more glass, I didn't want to mess with it. I've got a UV filter. I think it's attached to another camera. Not sure what that camera is, so I'm not going to worry about it right now. And it just forces me to do more focusing. So every once in a while we can see that there's a lighter area coming through here. But again, that is just a whole lot of just bad atmospheric seeing, just distortion. So there's not a whole lot that we can do. But on the plus side, I am glad we started later than 8 o'clock at 8:30. Otherwise, we'd just be sitting here even longer, waiting for Mars to stabilize. But we can do other stuff. So Neptune. All right, yeah, let's go ahead and do Neptune. How am I going to do Neptune? Neptune's not going to be too easy. So first of all, I have to blow this way up, because Neptune is going to be a small target to see. I have to boost my gain. So I'll be able to catch it. So Neptune is going to be a blue disk, where you would see stars as points of light. This will definitely be a disk. All right, so let's go hunt Neptune down now. This ought to be fun. Well, actually, let's do this. So, do I have this synced on Mars? I have it synced on Mars. This will not work terribly well. I know this isn't going to work terribly well because, again, the scope is not. It's aligned, but it is. There's just way too much slop in the gears. So we're going to do slew to Neptune. And you can hear it in the gears. So this was actually a donated telescope to the club, and we've been using it as a telescope for star parties. So our outreach coordinator, Patrick, has had this in his house. He's been using it, taking it out to sites, and showing the night sky to people at our public star parties at Tandy Hills, at Dinosaur Valley, various libraries, and other community organizations. But we're just not doing any public events right now. It is too hard to control people from crowding around. So we're just not doing it right now. Let's see. Ooh, I think I see Neptune in my finder. All right, cool. So I'm going to go back to the handset, and I'm going to try to get Neptune in the field of view. So here we go. All right, so got nothing right now. Let's see how close I can get it. Up, over. There we go. Jeez. Almost had it. I just want to center it. What I want to do is just want to center it. Not really too much to ask. Okay. Yeah, that would be Neptune right there. Not much to see. Now, usually when we're seeing it in a telescope, especially a really good one, and when it's up higher in the sky, it looks like a really, really small blue disk. But when you're seeing it in comparison to stars all around it, it is really obvious that it's a planet. Even through the telescope, it's not twinkling. This is atmospheric distortion. The scope isn't pointed up very high. It just is what it is. We just have too much distortion right now. There's haze up in the atmosphere. There's not much wind down here, but upper levels, that's totally different story. So that's what we got. That's all that we can see of Neptune right now. So that kind of sucks. I really hoped we could see something else, but I just don't see it. So I want to bump this up. I want to see what else, any other stars are popping through. This is way too long of an exposure, but that's okay. So definitely it looks like a disk. Do a longer exposure. I'm going to bump up the gain just see what else we can see. And there's nothing else really around there. This is definitely the brightest object in that area, which is bright, which is what it should be. Yeah, we don't have anything right. Oh, hey, Triton and Nereid. So it's kind of interesting. Look how far out Nereid is from Neptune. It's way out in its orbit. That's pretty neat. I'm not sure how close it goes off the top of my head. That's not too bad. So we've got Neptune right there. Yeah, what's a million miles among friends? It's not bad. So, yeah, did you think you could see Neptune today? I figured we would. So, what else we got? The moon is not up yet. That's a good thing in many ways because it tends to wash out the sky. But we're going into, what is it? We're heading toward third quarter. It's still gibbous phase. So, it's still kind of bright. But this is not a bad time to do imaging in the early evening if it wasn't for the fact that the atmosphere just isn't very pleasant right now. Nobody likes dead air, so I have to keep drinking so I can keep talking so there's no dead air. Unless y'all just want to hear sounds of the highway or sounds of the airport as planes and helicopters fly overhead. And when was it? It was it was actually last weekend. Last weekend I was getting set up and someone was flying a drone overhead again. So they orbited around and I guess they were seeing what I was doing. I had my little outdoor studio set up. I had the telescope set up and they were flying overhead and seeing what I was doing, and then I went further on. Got Jupiter. So we've seen Jupiter, we've seen Saturn. Mars is just a bit higher. So another airplane is coming through. Are we going to catch it? No, we're not. Yeah. I'm just kind of bummed. I really thought that the atmosphere was going to be a little bit better today than yesterday. But it's just not that great. Nothing we can do about it. We just kind of deal with what we got. But yesterday I was not ready to do this. So there was a whole bunch of stuff I was trying to get fixed, trying to get working. But again, it is what it is. Let's see what else we can see. I want to see if I can pick up something else here. So we got Neptune. Ceres is going to be a little bit lower. I want to see if we can find Ceres. So Ceres is the largest asteroid. It's 500 something kilometers across, something like that. I want to do center Ceres. Let's take a look. Let's go ahead and just, let's see. First, I want to slew to Ceres, and it's not going to be anywhere near it. But we'll find it. So here's Ceres. That's what it kind of looks like. So we're looking at one of the poles here. So Ceres is an asteroid. It is the largest asteroid. It's so big you can basically consider it a minor planet or a dwarf planet because it is round. It is large enough that it is able to be round. Some asteroids are not large enough. Some of them are so small that they are also, what's the word I'm looking for? They're held together by gravity, but just barely. Think it's a rubble pile held together by gravity, and there are some which have like two different lobes. And if they were any bigger, they would collapse, but they're not. And so these two lobes just they're stuck together. And it's not that they're orbiting, it is one object, but they just kind of stuck together in these two lobes. Ceres is large enough that it is a globe in and of itself. Right? I see it in my finder. I can see it in my finder, which is pretty dang cool. So how big is this? Let's get some information on it. Magnify, show info. Let's see, Ceres, dwarf planet, 476 kilometers. Okay, I thought it was like 554. All right. Close enough, right? Good illumination. Wow, pretty tiny, pretty tiny. Oh no, well, hold on. Where was it? Radius. That's the radius. Okay, so I was close to the radius. I thought that was the diameter. So the diameter is 905 kilometers. Okay, that's pretty good. Okay, cool. So let's see. Position in sky. General information. What I want is how bright is it? Description. Oh, here we go. So this will be magnitude. Where's my magnitude? Position in space. Other data. Apparent magnitude 7.44. That's not too bad. Okay, I can see it in my finder. I'm hoping I'm seeing it in my finder, and that it does not look like it's noise. All right, let's figure this out. I'm going to do this. We need to figure out what we're looking at with Ceres. I have something here. I've got something here. I'm going to boost this gain 10%. So this is nebulosity. Let's do longer exposure. Let's do it. I'm going to do a 2-second exposure. I'm going to do 50% gain. 9. Oh. How about 100? How about 500? Let's see how noisy this will be on a 2-second exposure. Well, there we go. All right. What are you seeing? We're seeing some stars. That is way too much gain. Way too much noise. Anything? Next image. All right, let's try 100. I do not need so much noise. What I need is... This is really what it is. It's sitting here and it's playing with it until you've got something that you can actually use. On a 2-second exposure. I'm going to do a 3-second exposure. What I'm doing is I'm just leaving it open for a little bit longer so I can find some of these stars, so the stars pop out from the background. Suppose I could do a longer exposure. See, that's too much. Do a 5-second exposure. Okay. I can see stars. Lots and lots of stars. There we go, that's better. Okay. Where is Ceres? Where is Ceres? Ceres is going to be somewhere in here. Now it's time to figure out where it is exactly. Oh, jeez. I don't like that, how it gets dimmer. There we go. Okay, a little bit brighter. All right. Do I need to do abort real fast? Advanced. No binning. I don't have anything special in there. I was hoping to do... where's my rotate? Image rotate. I need to do flip. Flip vertical. I think I need to flip vertical. And let's try it again. This is on frame and focus because we don't want to do anything special. 5-second exposure. All right, here we go. Now we do this. Yep. Come back to here. Zoom way out. Now we look for stars. What's our pattern? What were we looking at last time? Last time we were looking at this pattern here. So I want to find this triangle of stars and one. Oh man. Are we going to be able to find this? I don't know. So let's look at the finder again. Anything? Anything? I don't remember what this offset is. But we got a 5-second exposure. Triangle, here we go. Does that look right? It's a triangle. A triangle? Are we looking at it the right way? That looks like that triangle, does it? Maybe. Maybe. Flipping back and forth, kind of. It's the orientation. How do you gotta move your head this way or move your head that way to get it just right, because it's kind of aligned right. It's just really hard to tell. Maybe this isn't a triangle I'm looking for. I'm going to be looking for this triangle. Oh, this is fun, isn't it? Oops, wrong one. What am I looking for? I don't even know if I'm looking at the right location, honestly. I want to say that this is the right place, but I can't be sure. I can't even be sure. All right, let's do this. Maybe. Let's jump back to Mars. We will mess with Ceres later. I want to get to Mars. Well, so to speak. Or first, actually, now let's go to Mars. Low in the sky. Wait, now. Home. Now. 9:33. Yeah. Okay, so we got... I hate how these labels disappear. Ceres. Get back to Mars. Get your scope to Mars. I'm terribly sorry. I apologize for that. Center. And we will go ahead and not sync, slew to Mars. And then we'll fix it again. Alright. Okay. So was Titan visible in the Saturn image? No, it was not. Oh, I didn't bother boosting the exposure. We can do that. We can go back to Saturn too. It is still, let's see, where's Saturn? Yeah, Saturn, Jupiter are still well above my roof line, so that's fine. All right, jumping onto here. Whoops. This would be here. There we go. There's Saturn, or Mars, I should say. So let's drop this down to 1 second. A gain of nothing, nearly nothing. Okay, so that is close to where I want to be. I'm hoping this will work. I'm going to push this over. This is my finder scope. I'm going to push it over in this direction. And, all right, what are we doing over here? So, yeah, we should be able to see. Let's turn down again. We should be able to see it fairly quickly, fairly easily on here. All right, let me go back. Go. Moving. Good enough for now. All right. Yeah, it's still wobbly. All right, let's get the gain way down. And it's better. Oh, it's that. All right, it sounded like a pretty big bird directly overhead. All right, it is better. It's actually a little bit better. You can see a little bit of the ice cap right there. I'm gonna boost the gain. See what we can get. No, I really can't. It's got to go down. Every once in a while, there's like a little white patch that appears right there, and that is the southern pole. Yeah, there it was. It like every couple of frames. It's every couple of frames. It kind of just barely gets in there. So it's close. But you can actually see it better now than we could even, what, 20 minutes ago when we were looking at it last? It looks a lot better now. Oh, there we go. So we can see some more detail out of it. It is still swimming, but it is much better. It's a little bit higher in the sky. It does look better. We can see this lighter area cutting through the darker area here a lot better than we could before. So it's not half bad. I'm going to resync. Sync on Mars. So what are we looking at? This is now. All right, so we're looking at Hellas. Here we go. So we're looking at the Hellas Basin. That's going to be here, right? Or is that going to be here? Remember, this is flipped. No, Hellas should be right there. If we're looking at it, Hellas should be there. And I'm going to take this, move it off onto another one so I can go through. All right, so what are we looking at? We're looking at the southern pole here. Looking at Hellas Basin, which would be right over here. This is... Oh man, I think we actually have additional rotation. Never mind. This is Hellas right here. Oh, that's how we're doing it. Southern pole. This is Hellas right there, not over here. This is Hellas. And then we have, what is this region called? Ceres Major. So this is Ceres Major, right in this area, right here. And what is this dark area right there? That dark area would be, or is that whole area considered Ceres Major? Terra. We have a whole lot of craters. It's on my map, but there we go. So every once in a while, a little bit of white pops through. I don't know if y'all can see that. Let me know if you can see that. A little bit of white, and then because I can, I'm going to recenter it, and then we'll do some zooming. All right. Yeah, that's annoying to get up, but oh well. All right, let's get a little bit of zoom in on there. So again, Hellas Basin, the south ice cap, the south pole over here, and it comes in every once in a while. It comes in. I'm looking at my monitor, my output here, and every once in a while it comes in, so it's not too bad. Not bad at all. All right. What is this region over here that's coming up? Oh, it's rotating away. Sorry, this part is rotating away. So axis of rotation, or sorry, direction of rotation is in this way. It's from upper left to lower right. So we'll see Ceres Planatia go across. Yeah. I want to see if I can do this. What do I have here? What do I have here? Surface model. Good. So while that thing is going. We're waiting for it to come up. So I have on here, let's go back to Mars surface model, the default one. We have Mars, right? One of the cool things we can do with astronomy applications now is actually go to Mars. So we can go to, let's see, how do I want to do this? Select other, and let's see, orbit. Do I want to do the orbit? No, it's not what I want. I want to go to Mars. I want to orbit around Mars. Cursor tools. No. That's not really what I want. You know, I can't remember how to do this. It's been so long. Go to surface. I want to go to surface. I want to go to orbit. There's a way to do this. Let's see if I remember how to do this. Exoplanets. Oh, speaking of exoplanets, so there was an article today about 24 candidate planets, exoplanets that have been found, some of which, 4 of which I believe, had possible surface conditions that are better for the survival of life as compared to Earth. And something that they talked about was these are K-class dwarves. So our star is a G-class. K-class is a little bit more red. It's a much longer-lived star as compared to ours. Sol has been around for about 4.5 billion years. It will be around for another 4.5 billion until it starts to die. So it's right in middle age right now. It's really nice and stable. And some of these K-class stars can last 10 to 20 billion years. So you could have a planet that is habitable for much longer than Earth has been, and the longer planets habitable, then the more possibly the more likely it is that life could form on it. So, you know, we like to think that Earth is, you know, the one bastion of life in the universe, that, you know, it's the conditions on Earth are just right. It may not be. We may be a fluke here. Life may develop more easily on other worlds. We've just kind of lucked out. Something to think about. You know, we have hurricanes, we have tornadoes, we have earthquakes, we have volcanoes. You know, in the past, volcanic eruptions have created genetic bottlenecks by killing off almost all humans. There was an Indonesian volcano about, was it 75,000, 80,000 years ago, that bottlenecked us in Africa to a very small breeding population. Centered. And I think it was down to just a couple of hundred breeding pairs of humans, and from that the rest of us came. Here we go. Here's a little bit of ice cap that's just popping out. That's just barely there. I think another 20 minutes it'll be much clearer. But that's not too bad. I think we can just start some lucky imaging, see what we can get. So I want to do a little bit longer of an exposure. I'm going to cut my noise way down by dropping my gain. A little bit higher gain. Maybe not that high, maybe a little bit. Think not that clear, but let's go for it. Start capture. It's called Mars. Let's see what happens. So we're going to capture it and then play with it and see what we can get. Maybe it'll be good, maybe it'll be bad. We'll see. What time is it now? It is 9:44. It's not too bad. We'll continue this a little bit longer, and it is a work night, so I do have to be up in the morning. So I will not do another 1 a.m. star party tonight. Gotta pack everything up because I'm not going to leave this thing outside for the sun tomorrow and start work bright and early. Hey, there we go. There we go. I can see the ice cap coming in. It's getting better and better. Not bad. It comes and it goes. Again, it's just atmospheric seeing. I think the focus is good. The focus looks like it's okay. It's just atmosphere. It's still low in the sky. There we go. Now, I have to say that other times of the year, Mars is much, much, much smaller. I've tried to image Mars when it was about that big in the field of view, and you really can't see much. So it is significantly bigger, significantly brighter. Not too bad. So Peter's asking, let's see, top menu options. Okay, so for Sharp Cat Pro, got general settings. You can go ahead and pick out a number of cameras. It'll do the webcam. It'll do ASCOM camera drivers as well. And I have a Celestial Nightscape, and I think the latest Windows patch killed it. So I don't think I've tried to use it. Windows is not picking it up anymore. So I'll probably have to get rid of it and get a newer camera. But it does just fine with ZWOs. Basically, in order to use this, you install the camera drivers, and then once you have the camera drivers in, it works just fine from here. You can do a full screen. Ooh, full screen. There we go. How's that? Now you don't have to look at the rest of it. But I don't necessarily want full screen. So let's see, where is my F11? There we go. I want to be able to switch between. So we got what? Options, full screen, capture, tools. What does capture have? Stop, start capture. You can do flats. I don't necessarily need a histogram because we're not doing stuff like stars. We have the focus assistant, so if you were watching the pre-game show, we were using the Batonov mask feature to get really tight focus onto a star, which was just fine. But I think when we moved the telescope to from up high down to a lower altitude, it shifted the mirror and the focus was different, so we had to refocus it at that point. We were looking at Jupiter, at Io specifically, and it just wasn't in focus, so now we had to fix that. Seeing monitor, that's actually kind of cool. Make it a little bit bigger. I want to see what this does. Well, seeing's better, I guess. It's moving, but yeah, we're kind of I wonder if it's recording this or if it's recording, I honestly don't know, or if it's recording the actual images. I hope it's not recording this. So I don't know what exactly this is saying. To me it looks like the seeing is yeah. We have moments when it's good, moments when it's bad. But this is kind of a neat feature. Trying to see where the good points are, or we don't know. So, neat tool. Collimation experimental. Have not been messing with this at all. I have a different way of collimating it, but that's fine. Just various focuses and contrast edge. That's neat. Okay. Yeah. Again, have not used it, have not touched it. The only thing I've done is the Batonov mask because I have one. And if you wonder what a Batonov mask is, this is a Batonov mask. It is a piece of plastic and it is cut a really particular way. You have tines or slits that are straight, and then you have them at an angle. And the difference between them is you get this diffraction pattern on stars, on point sources of light. And by balancing that diffraction pattern, by making it even in and out of, or by making it symmetrical, it tells you when the telescope is in focus. There we go. Now I can see the ice cap. Now I can when it's over on the side. Okay, let's fix that. Oh, well, that's dumb. I have to stop the capture. That was kind of pointless because it went off screen. I guess we're probably going to have to redo that because when I tried to do it last time, oh, might as well. Let's just do it. Open up Mars. Let it process. Mars. Oh, I did it as an AVI. Okay. That's fine. All right. Automatically finding points to do. 16 points. That's fine. Brightness. AP grid. Close to edge. Replace. Fine. Fine. It's fine. Okay. At least I can't find anything bad about it. Okay. Does that normalize the brightness? No. Never mind. It's fine. Sharpened. Blend. Yeah, okay. So, planet. Do that. Let's start processing it, analyze it, and in the meantime, I've got to get Mars back in the field of view. All right. Almost. There we go. So, how's that ice cap coming? Every once in a while, every once you see a little bit of white. At least I'm hoping that y'all can see a little bit of white. I'm looking at the monitor, it just barely appears. The histogram. Yeah, let's see what the histogram shows. Not a whole lot. It's not bad. Not great, but not bad. Focus system, we're not messing with that. So I'm going to zoom in a little bit more, or a lot more. Yeah, it's this area right here where we should be seeing that white, right there. And you can see it is a little bit lighter there. Yeah, looking at my monitor on the other side, yeah, I can see a little bit lighter. I think my laptop screen is just bright, so it's harder to see. I want to bump up the gain, or now let's bump up the exposure just slightly. Let's see if it's more visible on the monitor. Slide this over. Just barely. Yeah, we can see some more contrast where Ceres is a little bit darker. Hellas is a little bit brighter. It just kind of went out now. But now I think I can see the whiteness right there of the ice cap. But yeah, it's still pretty swimmy. It's not too bad, but it's still pretty swimmy. So what do you got? 9:53. Yeah. All right. Anyone else want to see something? Or sorry, let me rephrase that. Do we want to see something else? I want to go back to Saturn for a bit. Yeah, let's do that. Let's go back to Saturn for a bit while it's still up. Maybe even Jupiter. Let's see if the Great Red Spot has slid over. That way we can come back to Mars still. Let it get a little bit higher in the sky. Make it a little bit less swimmy. That's not too bad. All right. Before we do that, I'm going to get to here. Got that. Oh, that's still processing. Okay. Well, it's got 4,000 frames to go through. Okay. Let's swing it onto Jupiter. Let's see, I'm going to zoom out. You can see it's way off. So I'm going to sync Mars again. And we're going to say, let's go Jupiter. So swing over. I'm not even going to try to find Pluto. I've tried. It is so hard to find. Last year when it was in the Milky Way, no. Or was it 2 years ago it was in the Milky Way? No, not even a chance. There are so many little stars all through the Milky Way, it's just not feasible. even for a small telescope. If you had a larger one and you knew exactly where to look, then it would be doable. So what are we going to be looking at? We're going to be looking at Io, Europa, Ganymede, and Callisto. Okay, so that's kind of cool. I'm looking at my finder. Way over. What is that? Oh, I'm still looking at my finder. I'm trying to see. There's so Jupiter is Jupiter is so far over that I am seeing I'm seeing a reflection from my studio lights onto the telescope. So it is bouncing around inside of my finder. So we may have that issue. And I do not have a dew shield for this. I guess I should make one, or I should get one. That would be really useful right now. So Jupiter, we'll see what we can do with Jupiter, but it just may be kind of hazed out. This is the best we can. So here we go. So we'll leave it on here, 19, that's fine. And let me dig up Jupiter again. Finder, there we go. Nope, wrong direction. Always in the wrong direction. Go. Direction. Big Jupiter, dim Jupiter. Wasn't Mars a lot bright in this? There we go. Now we got a great red spot. Okay. Let's look at gain. Blow up the gain, but have a smaller one. There. When we started, the great red spot was right over here. Now, it's right there. Seeing is still not great. All right, I'm going to take a bit longer of an exposure. There we go. There we go. Now we got a great red spot. All right, and we have a moon. What moon do we have there? That is Io. That is Io. All right, so let's do a quick capture. Start captures. We call it Jupiter. Jupiter enter. I'll see how much I can capture. Try to get some lucky imaging out of this thing. It's gonna get to the edge. It's gonna get to the edge, and it's gonna. When it gets to the edge, it causes errors with the stacking process. So we stop the capture. 290 frames. That's not a whole lot. In the meantime, let's see what this thing does. Did I do stack already, or I did analyze? I did not do stack yet. All right, cool. Well, let's let it keep stacking. In the meantime, let's do this. It is nice. Start capture again. One more. I hope it drifts off in this direction and not in this direction. But we do have the great red spot. We don't have any shadows right now, but we do have the great red spot. So that's a plus. And it moved over. So when we first started the night, it was right here on the edge. So pretty much in what, an hour and a half, it's moved over that much of the face. That's pretty good. That's pretty good. And we can easily see this is red. This is totally different color than the rest of it. We can see some detail in the banding. That's not bad. It's not bad at all. Start to touch the edge. Start to touch the edge. Move over. Can you kind of wish it to go in the other direction? All right. Point of view, that direction? Yes. Go in this direction. This direction. Come on. No. Hit the edge. All right, we're going to do stop capture. We got buffered frames. Okay, so here we go. This is something that I have noticed. If you don't have a lot of RAM on the machine that you're doing this in, my laptop, for example, I run out of memory. So this thing does have a limitation on the free version of, I think it's 2 gigs. And so I have a buffer on my frame, and I did it as an AVI. I didn't do it as an SCR. Because it's auto. Let's make it SCR. All right. Hey, it moved back. Hey. All right, let's start another capture. Call it Jupiter. We've got this going. Let's let it capture. And, okay, what I was saying before I interrupted myself, if you are doing stacking at the same time that you are doing capturing, the system can't keep up with both. And so what it does is it dumps frames into memory. But if you hit the max of frames in memory, it just drops frames. And so you're doing fine. You're doing 14, 15 frames a second for, minute, 2 minutes, 3 minutes, 4 minutes. And then as soon as this thing hits the limit, now you're dropped down to 2, 3, 4 frames a second. And it makes a difference, especially when you're doing this lucky seeing. Here we go. All right. I thought Jupiter was 12 hours. Maybe not. Maybe it is under 10. Is Saturn under 12? Saturn must be under 12 then. All right, it's still kind of getting close to the edge. All right, let's see. I want to see this. Saturn, Mars. All right, let's see what we see with Mars in Photoshop. So this is from Saturday. This is from today. Yep, not pretty, but we can see a little bit there. I think I need to do a different type of stacking. I think that'll be better. Stop. 1,300 frames. All right, that's actually pretty good. That's pretty good. All right, I'm just going to head and do this. Surface that. Let's get an SCR. I'm going to go back to Jupiter. Grab the SCR. Let's see, hit analyze. Analyze. Oh, it's still thinking. It's still waiting. Because I think maybe we'll get a little bit better out of it. It's just not great seeing today, honestly. Just not great seeing. All right. Can analyze it. Oops. Analyze it now. Let it do its thing. There we go. Now it's starting to move back. If I do, you'll see it's analyzing at the same time. I'm going to do a quick capture. And you'll see everything's hunky-dory until memory starts being used. Fine on here. All right. That looks okay. I wonder exactly how many frames I'm stacking. This thing doesn't really say. I think I'm doing top 10%, but I'm not 1% positive. I really need to read the manual for this thing. Unfortunately, I think it's in German. So the developer is German guy. Oh well. When you want Jupiter to drift across the field of view, it doesn't. It goes in the other direction. Or it stays pretty much where it is. But when you want to stay where it is, it drifts. Thanks, Jupiter. Or the telescope. Stop capture. Alright, how far along is this thing? Do I do stack now? Did I get it? Let's see. And there's a trade. I've got something. Nope, wrong one. There it is. There we go. All right. That's still pretty soft. That's still pretty soft. So I'm gonna grab this. Terribly sorry about the train. That's something else I got to deal with. Let's do, what are we doing? Adjustments. We're going to do, again, same thing. We're going to do levels. We're going to bring this way down. We're going to brighten up the image, but we don't want to overblow it. As soon as we start clipping the white, you can see that area there where there's no data. There's no, I should say no data. If it's all gone to white, that basically means there's no data. We want it just before it gets all to white. And black is fine. I don't want to clip out too much black, because if you clip out black, that's what you get there. So I want to keep black, and then if I change my midpoint, well, that messes stuff up too. Could get to there, but I don't think I want to. I want to go ahead and leave it as a 1. My midpoint, exactly where I want it. Hit OK. Cool. All right, next filter, sharpen. I can do, was it smart sharpen? That's always fun. And again, I'm just messing with it just to see what I can pull out, what details I can get. This is overdone. This is way overdone right now. You can see that edge, the limb right there has issues, but I want to reduce the noise. I want to boost it back up. There we go. That's not too bad right there. Hit that. So now we can see, oh, we're picking up some details there. That's not bad. That's not bad at all. All right, here we go. What else? I actually have these here, except I haven't used them. There we go. And these are some plugins. It's Astra, and they're plugins for Photoshop. I have not had a chance to use them. I really haven't had any chance to use it at all. I just played with it yesterday, but I think it's like $30. The full version is $30. Otherwise, it puts in a big what do you call it? A watermark on all your images, which is fine. Just playing with it, testing it out. But yeah, I'm not going to mess with this right now. Let's go ahead and cancel that. So we've got this. I want to pull out more detail though, so instead of smart sharpen, I can do sharpen edges, and that should find something, anything at all. I think it's slow because this is trying to do stacking at the same time. Or maybe it's done. Oh, no, this is done. Never mind. Never mind. Well, sharpen edges didn't work as well as I wanted. So, anyone have any suggestions on sharp mask? There's a whole lot of noise though. I don't want to mess with the noise. But what I do want, and here we go. Nope, that's not what I want. But I do want to see. Oh, I know what I need. So I've sharpened it. That's not too bad for sharpening. What we need to do right now is adjustments in vibrance. Right? And saturation. Maybe not so much saturation. I want to pull out more details. I kind of want to see what the differences are in the colors. And that doesn't look too bad. You can actually see some of the details. You can see there's this little bit right here which kind of goes up. You know what? Forget this. We're going to do this. Image rotation, we got to flip this thing vertically because this is in the southern hemisphere. Here we go. So as this is going along, remember it's rotating from this side to this side, if I'm right. I think so. All right, anyway, whichever way it's rotating. This feature here is being pushed up while this one is being pushed down. So that tells me that the the Great Red Spot is rotating in this direction. So it's pulling this up and it's pulling this down. I don't remember which way it rotates in comparison to Jupiter. Is it rotating with the rotation or against the rotation? I just don't recall. But you can see this feature here. You can see this feature here. Up in here, there's some turbulence as well that you can see in the bands. That's actually pretty good. I'm looking over at my output monitor, which is a little bit darker, and it looks, I think this looks a lot better than my laptop monitor. My laptop monitor is not color calibrated terribly well, so everything is really bright. It's kind of washed out, so it's a little bit hard for me to see some of these features, but that's not too bad. Oh, so fire capture. I have not tried fire capture yet, but yeah, I've been using SharpCap now for a while, and it seems to work pretty well for me, so it's fine. The only issue I have, again, is that I have multiple ASI or ZWO cameras, and because I do, I can't have two copies of SharpCap up at the same time, so I can see what two of them look like. See the output from two different cameras. SharpCap will open up two different sessions, but for some reason, I think it's actually it's the way it talks to the drivers for the cameras, that the cameras are, while not active, they're available in both applications, and the way it's done, it causes both applications to just grind to a halt. I've been trying to play with it, trying to get it to work right, and what worked for me is I use Nebulosity for one camera, and I use SharpCap for the other. Nebulosity I typically use with my SBIG camera. I think it's STT 8300 mono, and I can control the filter wheel through there. I can do everything I need through there, but Nebulosity works really well for that one, and then I use SharpCap for the ZWO cameras. So that's not too bad of a Jupiter, especially when we compare it to the live view, which is here off to the side. So we're not capturing. I'm going to recenter it. So with the live view, we can still definitely see the Great Red Spot, and yeah, it's quite visible. But yeah, this is way blown out. We don't want to do that. I don't want to turn the gain way down either. So this isn't too bad. I'm going to do a quick capture again. Just SCR, blah blah blah. You got it, SCR, yeah. So we're doing 24-bit RGB. This is the max area that the camera can do, and this is not an application that likes subframes. So there's a trick with some cameras that you can do. It's called subframing, where basically I can draw a bounding box around what I want to take an image of. I think it's the camera that can't do it. I think the application should be able to. But what that lets me do is take an image like this of Jupiter, and I don't care about all this stuff around here. All this black, I could care less about it. There's nothing in there that interests me when I'm doing planetary images. I just want something tight around Jupiter. So I can say, all right, this is the only part I want data from. So this is all that it records. And I can record this much, much faster than I can the stuff around it. So it's like, for the entire frame, I'm able to do right now, what is it, 10 frames a second. It's doing some additional processing because, I guess, because of the exposure. Exposure is a bit longer. So if it was shorter, I could do more frames a second. If it's longer, fewer frames a second. But if I just crop it around and do the subframe, I can do, depending on how small it is, with another camera that I've got, I can do, I think, a maximum of 150 frames a second. So there you go. And that's when you really want to get this optimal seeing. You want to get the exposures as small as possible, so you don't have like smearing of the images from the atmosphere. And there's correctors you can get. I know that SBIG does what they call adaptive optics, which it's really not meant for atmospheric distortion like this for planets, but you can always try to use it. And what that is, it's a little piece of glass, and it has two axes on it. And what you do is you have an auto guider. You have another camera which looks at a star, and it sees how that star is kind of wobbly, and then it moves that piece of glass in a particular way. I think a couple hundred times a second is what it can do if necessary, or maybe, well, I don't know. Let's say 10 to 100 times a second, whatever it takes, in order to stabilize the image of that star. And they're not cheap. I think that one, the one that I saw, was about $800 or so. But if people are using them, you can sharpen up your star images, which sharpens up images overall for your astrophotography. I still think that is pretty cool right there. We can see the great red spot. All right, let's try this again. So I'm going to open it. What did we just make? Jupiter, another SCR. So this is the latest one. Yeah, so it's nice. It does a timestamp. We had not quite 2,000 frames with this one. Analyze that. Yeah, that's still not terribly pretty. I don't know if you can. It's yeah, that's one frame. So, and the sad thing is earlier this week when I was playing with this, I think Wednesday, Thursday. Oh, sorry, last week when I was playing with it, the images were pretty good. It was actually significantly sharper than it is now. So I think we're just having a night of not the greatest seeing, but we're doing the best we can. All right, does anyone have any other questions, any comments, something you want to see, something you want to share? It is now 10:17. I'm going to swing it back on Mars. We can get another view of Mars. It should be a little bit better. If Mars is swimming like what Jupiter's doing right now, I'll be relatively happy. All right, so did we do analysis? I think we did analysis. Yeah, let's go ahead and do the stack. Yeah. I've got to figure out how to get only do 50% or higher or something. Because I'm still not certain how to get this up. Does anyone know how to use this? Astro Surf Wheel, do you have any suggestions on the stack options right there? What I should do? I have not. Number of frames to stack. Yeah, processed. I guess percentage stack. Other than that, I don't know. If I want to do color TIFF, that's fine. I don't want to mess with that. All right, so we've done that. Now I've got yet another stack. Let's try. Back into Photoshop. Let's compare it. Think it's better? I think it might be a little bit better. So first things first, image rotation. I'm gonna flip it vertically, come in, crop it down. Zoom in, let's do some sharpening. No. Do unsharp mask or smart sharpen? I think it was unsharp mask. Get that to pop. That's not horrible. Well, it's not great. Yeah, not what I want. Definitely not what I want. Don't think that's what I want. I think I wanted the other one. So that was unsharp mask, smart sharpen. There we go. That's what I want to see. Yep. All right. We can see that. And next, I guess I should have probably done levels first. for any sharpening, but that's fine. I just get that right there. Okay. And let's look at curves. Curves. Don't want to do that. Again, I've got a second monitor I've got to look at, because third monitor I've got to look at just so I can see what the colors are when they go out, because it's just so washed out on mine. I think that'll be fine. And let's get some more color in it. Let's see. Let's do auto tone. Nah, that's not ugly. I mean, it's totally washed out for me, but that's not ugly. Let's do auto color. That's not bad. What auto contrast? No, I think we have contrast pretty good. No, maybe not. Let's do. Oh no, that's. Actually, that is what I wanted. I did want vibrance, not hue saturation. Push up the vibrance just a tad. Way up high. I don't think it matters. Saturation. Now we can see some of these colors a little bit better. Turn vibrance way up. Nah, it's too much. So about there. That looks pretty good. Okay. That's not horrible. What do y'all think? That is not horrible. We can see some detail. Definitely see great red spot right there. We can see this pattern here in the band. This part that goes up. Part over here that's going down. We can see some turbulence all through here. That's not bad. We can see the color in the banding. Reds and browns and this kind of yellowish area here and here. That's actually not too bad. That's not bad at all. I think I'll go ahead and post this to the Facebook site later on today. See, what other adjustments can we make to this thing? Ooh, shadows and high. Ooh, there we go. Shadows and highlights. Want to mess with that? Shadows. Blow up the shadows. No. Make shadows dark. Yeah. Lighten up the shadows. What about highlights? Yeah. Look, it's 2010. Is it? Yeah, 2010. The monolith is falling into Jupiter. All right, I should stop. We can do a whole lot with it, but I don't really want to. What a color. More color. Nah. Mid-tone. Oh, here we go. No, that's not what I want. Cancel that. Cancel that. We'll stick with this. This isn't too bad. Usually when I'm doing my my image editing, I'm doing it on a calibrated screen on my workstation in my office, not on this laptop. So this color on here is just, it's horrible. This is not meant for editing, but for generalized astrophotography, stuff like that is absolutely fine, and I can just do whatever I need to do and then do post-processing later. Remember the mantra of Hollywood, we'll fix it in post. All right, so we've got Jupiter. Let's get back to, it's gone. All right, where is it here? Close enough. Starry night. Let's send it back to Mars. Back to Mars. I had it synced on Jupiter. Close enough. All right, what are we looking at now? Oh shoot, let's just go Saturn. We'll just tour over. We'll do Saturn, and then we'll do Saturn. Then we'll go back to Mars, and then we'll call it a night. It is now 10:24. Yeah, we can do that. Look at Saturn. Look at Mars. And then we'll call it a night. So back to here. I think. Oh, there we go. So close. So close, and it slewed off. All right, let me go fix it. there's Saturn again. And if you recall, it's a little bit further away, a little bit smaller, so a whole lot dimmer. All right, I want to leave it right there. Let's boost the gain then. There's a Cassini division. We can see it again. Yeah, there we go. Punch up the gain. So there's a little bit of banding right through here, but we can make out the Cassini divisions popping in and out. I think the focus has gotten a little bit soft. Yeah, I'm pretty sure the focus has gotten a little bit soft. So one of the issues with this telescope is it is a steel tube. So as the temperature goes down, the steel will contract. And because this is canadioptric, it is a spherical mirror in the back. It is I think it's also a spherical mirror on the secondary, and then a corrector lens. Tiny changes in the distance between the corrector, between the secondary and the primary, make huge changes in focal length. That's one of the reasons why it's so small. You have a telescope which has a focal length of 2 meters compressed down to, I don't know, what is that? 50 centimeters, and yeah, so it is much shorter than it would otherwise be if it was a lens-based telescope. So I think that's what's going on, is we have an issue with focus at this point. We can try to fix that. So let's see. All right, I have to recenter, then we'll try to focus it. Is that better? Is that worse? About the same? I think it's a little bit worse. Hard to tell. Let's get it back. I don't think it's going to get much better than that. Yeah, I really don't think it's going to get much better than that. You can always toss it onto a star and do the Batinov mask again. But yeah, I don't see it getting too much better. But there we go. They got Saturn, and just for kicks and grins, I want to bring up Starry Night Pro. We're going to see if we can find Moon of Saturn. Where's Titan? Oh, Titan's way off. Titan's going to be way off. We're not going to see Titan. Yes, we are. We're going to see Titan. Here's Titan. There's Titan right there. So here's Saturn, and this is overblown, remember. But that is Titan right there. Here are the rings, and it is in line with the direction of the rings. So here is Titan. And we're picking this up in a 60 millimeter, I think it's 60 millimeter. Yeah, I think it's 60 millimeter guide scope. So there's Titan, but Titan's off of the field of view of the of this one. Titan would be somewhere over there. Well, let's see. I don't know. Maybe we'll see it. Let's boost the exposure. Actually, no. It'll be on this side. All right. Let's just pick it out. I'm gonna go exposure. No, not exposure. Gain. Where's my gain? There's my gain. Gain way up. All right. Let's see if we can move Saturn over to find Titan. It's not Titan. Yeah. we are looking in the wrong direction. If Titan's over here. Don't see Titan over there yet either. Almost, here we go. Almost. Titan. Titan should be coming into the field of view any moment. Anything? Oh, there it is. That's it right there. At the bottom of the screen. That would be Titan. Alright, so let's do this. Let's make it a little bit longer of an exposure. And boost the gain. Yep, that would be Titan. So Saturn, it was incredibly overblown, but we've got Titan right there. Okay, so this is Titan, moon of Saturn. Okay. Okay, alright. And, alright, we got Saturn, we got Jupiter. Got some decent images out of Jupiter. I don't think we're going to get too many decent images out of Saturn. I'm going to test the focus on here real fast. Let's see if we can get Titan a little bit tighter. No pun intended. That was just too obvious, wasn't it? How's that for sharpness? That's not terribly sharp. I wonder if we can put the mask on. Oh, no, it's just too dim. Fine. It's too dim. Add more gain. Add longer exposure. There we go. Now we're seeing a diffraction pattern. But, yeah. It's not going to be pretty. There we go. That's not bad for sharpness right there. Okay. That's not bad for sharpness. I think it's just not going to get any better than that. I think collimation is still not quite exactly where I want it, but that's all right. We're not too bad. There we go. So we're looking at a moon of Saturn again, Titan. All right, then let's go to Mars. Swing on the other side of everything. Sink back on Saturn. Yeah, there's so much slop in the gears. I'm just gonna have to. I'm gonna have to take it apart. That's the only thing we can do is just take it apart. We've done it before. Ooh, the moon is just now coming up. All right. Well, here's Uranus. Maybe we can pick up Uranus as well. How about we do Uranus next? No jokes. Heard them all. Every single time we've heard them all. Slew to Bianca. Slew to Uranus. Yeah, let's recenter. Center. There we go. So many moons. Center on Uranus. How's that for featureless? Absolutely featureless. Okay. It's going. It's going. All right. I'm looking at my finder. Where's Uranus in my finder? Let's zoom out. Oops. Zoom out here. Zoom. Okay, so it's getting close. I really, really, really should. This isn't anywhere near the area, is it? I'm looking at my finder. My finder's not. I can't tell. I really can't tell in the finder. I'm gonna do a 5-second exposure, see what I can see. I see a couple of stars in there. I'm trying to pick out a pattern. I can't. Wait. I got the pattern. Okay. Hold on. I got it. I see it. Let me zoom in. I see it. All right. So I can see 2 stars, 1 star, another star down here, here. This is what I'm saying? I can see 1, 2, 3. Okay, I'm looking in this area right now. Then I'm looking down to here, and I can see this star. No, I can see this. What am I looking at? This is really hard to tell. I'll show you. Yeah. So I have these 3 stars. They look like they could be these 3 stars right there. Then I have star here, star here. Doesn't quite correlate. Star here, star there. Not exactly. So Uranus would be further down. All right. Yeah, I know I'm not exactly in the right location. So I'm going to go down to here. Let's magnify this. Yeah, I'm going to, it should be somewhere down here. Let's do that. Right direction, wrong direction, wrong direction. I'm hoping we can see it. Needs a longer exposure too. It's wrong direction, isn't it? Yes, it is. What? We'll have to do Mars first. Yeah, we'll sync on Mars first, and then we'll go to Uranus. Way off. We're way off. Go. Right. Mars is close, but I don't need a 5-second exposure. We can just go with 1 second. I will grab this, push it off, and then go back to here. Here we go. There's Mars. Whoa. All right. It's big. It's bright. Gain is way high, so a lot of noise. And we do not need this long of an exposure. All right. Get the gain down. Hey, we had some rotation. Ceres was further over here. We've gotten some rotation in the last bit. And the polar ice cap is visible. It is a lot more visible now than it was. All right. So I think you guys need to see it a little bit brighter. There we go. A little bit more. That's too much. How's that? That's a little bit too bright. So I'm going to turn the gain down just a tad. That looks pretty good right there. All right, I'm going to recenter. Yeah, how's that? Okay. All right. Yeah, the ice cap is a little bit better right now. I don't think my focus is quite right, but this is definitely a little bit better, and we can see that Ceres Planatia moved over just a bit. It was closer to here on earlier images, but the ice cap is still the same location. Here's Hellas. Hellas was a little bit further over as well. So yeah, here we go. A bit swimmy. It's still swimmy. Yeah, the night is not nearly as nice as it was, even last night. We're just not having very good seeing. But yeah, it is what it is. Just deal with it as best you can. But tonight is the closest approach of Mars to Earth for a while. I remember the next time it'll be in. That's a good question. When's the next time? I don't recall, and it'll be a couple years. So typically Mars is going to be a lot smaller. It's going to be a lot dimmer in the field of view from a telescope. But tonight is making its closest approach, and then on the 13th we have the opposition. So the opposition is also pretty close to the, if not the same as the. What is it? Thinking apogee, perigee, but it's not. It's apohelion and perihelion. So in this case, it is the perihelion. It's the closest approach to the sun. So this is the Martian summer. Something that's also interesting about the Martian summer is this is also when we see large dust storms because the atmosphere is warmer. There's more activity. There's more wind. Wind picks up dust. Dust heats up the atmosphere even more because it absorbs radiation from the sun. Mars gets warmer, bigger dust storms, and we can actually have dust storms that cover an entire hemisphere. So Mars just kind of turns into this hazy, featureless kind of blank disk. But I don't think there are any dust storms going on right now. But again, this is the equivalent to the summer solstice. Is it? No, it's not equivalent to summer solstice. It is just the closest approach to the sun. I don't remember. I'm tired. It's 10:44. I said we're going to be done at 10:30. Already. 15 minutes after. I don't see any other questions, so I'm going to resync this. I hope this is going to work. I really want this to work. I'm going to resync on Uranus. No, not Uranus. Resync on Mars. See, it's off. It's way off. So I'm going to do sync on Mars. And I'm going to go to Uranus. Here's Pleiades. Pleiades is up. So resync. Slew to Uranus. Let's see what we can see. Let's get a 5-second duration on it. I want to see Uranus tonight before I go to bed. All right, now I see Uranus. All right, I see it in the field of view. So, yeah, I have the finder scope, so let me move it. We'll go 1, 2, 5. Counting how long I do holding down the button. I know how much it's moving. It's kind of hard to see guide scope or with the got the finder in the field of view, but I've got it. I'm close. Since I'm close, let's do this. And I need to bump up longer exposure and way more gain. And all this color, all these dots here, this is just noise. But we should be able to see something. Just a minute. There we go. See that? You see that? See the color in that? That is a planet. That is Uranus, and you can see it's kind of that blue-green color. So let's take the gain and get it way down. Oh yeah, there we go. There we go. It is definitely blue. It is a disk. It is not a star. It is not twinkling. I'm gonna do a little bit longer of exposure. That pretty blue? See how long I can get that exposure. There we go. How's that for pretty blue? That is Uranus. Yay, we captured Uranus. I like that. Actually, we managed to be able to get Uranus in the field of view. That's not bad. It's not a bad way to end the night. Let's see. I'm not going to do any lucky imaging of this. There's not much of a point. It's featureless anyway, and I can tell my collimation isn't quite right. So I will spend some time this week ripping this thing apart. I'm going to have to take it all the way down to the gears and clean it out and then put it back together again once everything's all tightened up. Hopefully I'll be able to get the wedge. And once the wedge is on here, I think the tracking will be a lot better. I'll be able to do better imaging. And yeah, we can have fun with that. So winter is coming. Winter means colder temperatures, which means that cameras work a little bit better. And we have the winter constellations coming. We have Orion Nebula. We have the winter Milky Way. And we'll be able to do some more imaging. There's a lot of interesting stuff in the winter that we can image. So hopefully I'll be able to go down to Grandview again and do some dark sky imaging from there. Hopefully I will be able to fix my mount and use it again. I'm also looking at getting a new one. We'll see how that goes. But in the meantime, let me recenter. Hang on. Recenter. Go. Nope, wrong direction. Wrong direction. Go. Those sloppy gears. There we are. Okay. Yeah, there's just way too much slop in those gears. So again, we have Uranus here. We have, so we've seen Jupiter. So we can do a quick run through again. What have we seen? We've seen Jupiter. We've seen Saturn with some not great imaging. We've seen Mars. Here's Saturn from a couple days ago. Jupiter from earlier. No, this is Saturn from today. Saturn from today. Jupiter from earlier with the great red spot over here. Jupiter later on. Well, let's fix this. Image rotation so we can see what it looked like actually. Vertical. Here we go. So we had the great red spot over here earlier when we were taking images. Jupiter moved over, and so did the great red spot. We could see this, and actually what I want to do is this. Here, right here. So I want to see the difference. Oops, wrong way. This compared to that. Or was it this? No, Saturn. Mars. What's Mars doing? Oh, moved it over. So there's this earlier. We had this earlier. And we had this. And that. So even between the span of these two images, we have motion. You can see the rotation. Is that cool? Just within a couple of minutes. So we took video, and then paused, processed it, and then took another video. So just within that, we could see this. So you can see we can't do something like an hour-long video and try to get tens of thousands of frames and then stack them because the planet rotates too fast. Now we're going to be smearing the image. So we have to take these shorter exposures, a minute, 5 minutes at the most, really. And from there, do the lucky imaging, take those frames, stack them, try to get a better image out of it. This is not too bad. I'm not super happy. There's issues with collimation, there's issues with the atmosphere, there's issues with tracking, but all in all, it's not that bad for processing on the fly. And this also allows you to see what it takes to do the processing, that it's not just take an image and you're done. You have to get some work. You have to put in some effort. You have to put in some work in order to do this. It's not just whatever I see is whatever I get. I mean, it can be that way, but you're not going to get the best possible image that your equipment is capable of getting. You just have to work at it. So we've done Jupiter. We've done Saturn. We did Mars. Terribly great, but we did Mars. This is from last night. And we also saw Uranus. Neptune was barely there. But yeah, we definitely see Uranus. So there you go. Any questions? Any last issues? No, I don't see. Okay, how long does it take me to set up or wrap up after viewing? You have to pick up and put it away. Yeah, it actually does take a while. So the telescope I can actually leave out. I have it's called a 365 cover. I forget who makes it. Telgizmos. Telgizmos is the company that makes these covers for telescopes, and they have a couple different ones. One is just like a dust cover that goes over it, and the other one is it's called a 365, and you can order them in custom sizes for specific telescopes, or you can say, hey, I need one that will cover like a refractor that's this long, X long and X wide, and this is the mount, and this is how long the scope is, and then they will go ahead and cut and sew together a custom one just for you. The 365 covers are pretty cool because they're the inside has reflective mylar, like aluminized cloth basically, and it helps to reflect the heat. The outside is waterproof, and then it goes down around your mount, around your telescopes, and you can cinch it tight underneath, well, relatively tight. And even if it rains, water's not going to get into your equipment. About, I think 2 years ago, maybe 3 years ago now, I left my scope out, my mount and actually dual mounted scopes outside, because I was just too exhausted to put them up. And I forgot to check the weather. Um, so instead of putting up all my equipment, I took my laptop and I took the laptop in. So that was fine. But I left the telescope and left some other stuff outside, and I thought, it'll be fine until tomorrow. 4 o'clock in the morning, I hear thunder, and it wakes me up. And I hear pitter patter of raindrops on the window. And I was like, oh, it's raining. It took about 3 or 4 seconds for me to bolt upright and yell, telescope! And it woke my wife up. And I ran outside, and it was just pouring, and I could see the raindrops bouncing off my telescope when I turned on the outside lights. And that is not a good feeling. That is a horrible, horrible feeling. And everything was, it wasn't quite soaked, but it was close to it. So I had the dust caps, the lens covers on the telescope, so no water got into the telescopes. That was good. But the mount was totally drenched. Everything was just drenched. And the entire setup that I had weighed probably close to 150 pounds. I was actually under the patio trying to figure out what I'm going to do when my mother-in-law came downstairs. She was staying with us at the time because we had a new kid. And we just both ran out in the rain, lifted everything up, and brought in the entire assembly underneath the patio. And then you can't do anything right now. So we left until the morning. And fortunately, I was able to take everything apart, including the mount, and lay it out on towels in the sun and let the sun dry everything out. So I actually had to take the circuit board out from the mount, and there was water on the inside. Took absolutely everything apart that I could, and just left it out to dry. And nothing rusted. Everything worked just fine. So no issues. It was just that moment of panic. So I did get the 365 cover after that, and I do put the cover on the mount on the telescopes when it's even remotely likely that there may be rain. So cover goes on this thing as well once I'm done. As far as the studio equipment, I have studio lights, I have multiple cameras. I just pack everything up. So it doesn't take that long to do. Once you do it enough times, it's kind of second nature. You know where everything goes. You just kind of grab everything, you put it inside the house, and you worry about cleaning it up later. There are a lot of cables. I just grab the cables, put them in a box, and then I clean up the cables later. For me to set up the equipment from scratch, let's say for the telescopes, with my old mount, it usually takes me about an hour and a half to get just the mount set up, the telescopes on there, everything aligned. The broadcast equipment, I've got it down now so I can get everything done in about an hour to 45 minutes. And if I have to rush it, I can probably get it done in about half an hour. And breaking it down is usually about the same amount of time. For the broadcast equipment, for the telescopes, takes about an hour or so to break everything up and put it in cases and wrap up the cables and everything else. So it is a bit of an effort, and there's some times when you just go, I don't have the energy to set up the telescope, and those are times when it would be nice to have an observatory, and hopefully that will be maybe in the next year or so. Might be able to set up something down in Grandview, like a permanent roll-off or something with power, so I can have the telescope set up there. I can have a mount there. Everything is set up, cameras and monitors, and everything is good. And all I have to do is drive down, turn everything up, open up the roof, let it cool down, and just start broadcasting when I'm ready. So that's all I got. So I'm tired. It's 11 o'clock. It's right at 11 o'clock right now. I am going to shut down, cover everything up, and go to bed. But I'm actually happy that we were able to see Mars, even if it wasn't the best sight. I'm glad we could see the Jupiter and Saturn and Uranus, and I'm hoping that was Neptune that we saw, but I'm not 100% positive. Looking over, I can see the moon is just above the horizon. It just through the bushes, through the crepe myrtles. It is not visible yet to the telescope, so there's no point in really looking at that. And it's late, and I need to pack up, and I need to get to bed because I've got work in the morning. So, thank you everyone for joining me tonight, and we'll do this again soon. So, have a good night.